But first, I want to talk about LSP and their ability to bring together the rocket and the spacecraft.
Since the dawn of humanity, we have looked to the stars and dreamed of bridging the gap between the Earth and the cosmos. In the 20th century, NASA turned that dream into a reality by launching humanity into a bold era of scientific discovery. As pioneers of space travel, our best and brightest designed and built everything from the ground up, from launch pads to rockets, all of which were government-owned and operated. As NASA's science and robotics evolved, we encouraged a competitive launch market to develop, ushering in a new way to explore and discover through commercial spaceflight. Spacecraft customers from around the world, all with the same desire, reached out to find an expert at NASA for support. Thus, NASA's Launch Services Program was born. Our mission is to centralize NASA's launch services and address state-of-the-art customer needs when placing their spacecraft in orbit around the Earth, the Sun, or destinations deeper into the solar system. The LSP family is made up of a diverse tapestry of government and contractor engineers, analysts, operation experts, and business advisors, all united by a common goal: to get your spacecraft off the ground on time, on budget, and successfully to its final destination, wherever that may be. We match scientific and robotic spacecraft with the appropriate rocket and certify rocket performance and reliability. We support full-service missions, advisory services, and one-of-a-kind contracts. The Launch Services Program is the common thread that bridges the spacecraft organization to the rocket designer, and the spacecraft to the rocket. We provide long-term technical leadership and expertise from pre-mission planning to system verification and validation, all the way through launch. Whatever the vision or requirements, our team will be there, guiding our customers every step of the way on their journey through space. We are the common thread that connects the science world to the physical world by putting the necessary instruments in place. The thread that weaves NASA's industry-leading knowledge and support into the fabric of the commercial space market. We unite customers, capabilities, and culture to explore space through unparalleled launch services. NASA's Launch Services Program. We are Earth's bridge to space.
It is L-14 minutes and counting until liftoff. We've talked a lot about the history of Landsat, but we would be remiss if we did not point out the mother of Landsat, the woman who created and fought for it. Virginia Norwood was an MIT graduate and physicist working at Hughes Aircraft Company in the 1960s, and she knew NASA wanted a way to capture multispectral images from space. She set out to solve the problem, and through years of research, development, and testing, she created the multispectral scanner system that flew on the very first Landsat satellite. As a testament to her legacy, there is an entire group of women on Twitter who call themselves the Ladies of Landsat. They draw inspiration from Norwood as they highlight the work of underrepresented researchers, and we will hear from the co-founder of this group a little later after launch. Virginia Norwood could not be with us today, but we do have some of the Ladies of Landsat here at Vandenberg to see the launch up close, and we hope they enjoy it. Joining me now is Dr. Thomas Zurbukin, Associate Administrator for NASA's Mission Directorate. Thomas, thanks for being here. It's starting to clear up. We can actually see the pad now. Tell us, how does Landsat tie into the entire Science Directorate portfolio?
Marie, what an amazing day. I'm just so excited. And of course, this is the first of 11 launches in Earth science in the next 2-3 years, just from NASA alone. And in many ways, the way I think about Landsat, it's really the foundation, the contextual data in which we look at all the Earth science we do, the research that we're doing, looking at our amazing planet. Because of the nearly 50-year time, the way I think about it is almost like a painting. Our research is the paint the Landsat is the canvas. So it really belongs together very deeply.
Absolutely. And Landsat obviously looks down on Earth, surveying the entire planet. Does anything we learn from Landsat help us turn outward to explore further into the solar system?
Absolutely. You know, the work that we're doing in all of NASA, of course, expands beyond Earth science. We have missions that will go to the Trojans, a planetary mission, the James Webb Space Telescope launching later this year, and we use the very same technology that we're using for these analysis of the cosmos of other planets, looking at our planet. So yes, we learn from there to here, but very much we learn from the Earth science instruments to look at how we explore other planets.
Sure. I want to also ask you about this huge treasure trove of data available for researchers. It's available to the public. First, we have a quick video to explain that.
Landsat archives its 9 millionth scene. Each scene is a satellite image from space, about 115 miles wide. Researchers and, well, just about anyone can download scenes from the Landsat Archive managed by USGS. Landsat holds the title for the longest continuous space-based record of Earth in existence. That's 50 years of scenes like these, helping scientists and researchers understand how our planet is changing over time.
So we just saw a video there about Landsat having archived 9 million images and counting. We're adding 700 every day to that. Until the earlier 2000s, this data was not free. People had to pay per scene. Now that's completely free. It's available to anyone who wants it. Why is that so significant?
Well, it's absolutely essential to unleash the power of the data that we have. Of course, our partnership with USGS remains strong. They are our, if you want, translators of really the images to the application spaces in our world, whether it's agriculture, fisheries, and beyond. But by making the imagery public, what happens is that companies, non-for-profit or for-profit companies, can take those data and put their own data on top of it and actually add to the value of the Landsat data in ways that otherwise would not occur. So it's a huge stimulant on entrepreneurial thinking of the type that the US is known for.
And beyond Landsat, we're looking forward to launch in 10 minutes or so. But real quickly, what else are you looking forward to this year for the Science Mission Directorate?
Wow, it's an amazing year. Frankly, there's hardly ever been one like this. Just 2-3 weeks from now, around mid-October, we're going to launch Lucy to the Trojans. They're out there at Jupiter distances, bodies of the solar system we've never observed. The James Webb Space Telescope and 2 missions, one looking at the violent universe in X-rays, and then the first collision experiment of a spacecraft with a near-Earth object.
All right, Dr. Thomas Zurbukin, thank you so much for joining us. Enjoy the launch. And with that, let's send it over to Daryl and Mick to take us through these final minutes before liftoff. Guys?
All right, thank you, Marie, and welcome back into the Mission Director Center. We've been listening to the launch team and just got some great news from NASA Launch Manager Tim Dunn, who declared that Landsat 9 is now on internal power. That means things are looking really good.
Yeah, Tim Dunn completed his poll with the team, notified them that weather looks good, the range is good, spacecraft is on internal power, like you said, Daryl, and those are all good indications that we are go for launch at 11:12 this morning. So excited to hear about that. The next up, we will hear from United Launch Alliance launch conductor Scott Barney. He will perform at L-7, the ULA teams poll, where we will hear the team give their go, ready to enter terminal count. And as we mentioned earlier, Launch Director Tom Heater will give that final proceed to launch.
And, of course, a dedication going up on the rocket with his name on it. His son, as you mentioned, the launch director. We'll be listening for that poll, which is coming at L-7 minutes. If you look across the bottom of the screen, you can see we're at weather briefing. Coming up is polling, and we'll hit that at L-7 as we count down. 60 more seconds until that moment. As we look out at the rocket, we see that they've had a little bit of clearing. That doesn't affect the chance for launch. But, Mick, it's nice to see that there's a little more visibility 4 miles visibility, which is exactly the distance between this rocket and our host desk where Marie is and the launch viewing area.
Yeah, I'm feeling a lot better seeing some of that fog clear off, that Marie will be able to actually see something from where she's located with all the guests she has up there. That's exciting. Like we said, the weather is really cooperating with us this morning, and as this fog here in Vandenberg moves out, weather still remains go, and the United Space Force has assured us that we have a green all the way through launch.
And once they go green and once this thing launches, it will be the 2000th launch from Vandenberg Space Force Base, as well as the 300th Atlas. Let's listen in now as they conduct that poll.
L-7 minutes.
Status check to proceed with terminal count. Atlas systems. Propulsion.
Go.
Hydraulics.
Go.
Pneumatics.
Go.
LO2.
Go.
Water.
Go.
Centaur systems. Propulsion.
Go.
Pneumatics.
Go.
LO2.
Go.
LH2.
Go.
Has gas.
Go.
Electrical systems. Airborne.
Go.
Ground.
Go.
Facility.
Go.
RFFTS.
Go.
Flight control.
Go.
GCQ.
Go.
Operation support.
Go.
Com.
Go.
Umbilicals.
Go.
ECS.
Go.
Red line monitor.
Go.
Quality.
Go.
Op safety manager.
Go.
ULA safety officer.
Go.
Vehicle system engineer.
Go.
Anomaly chief.
Go.
Range coordinator.
Clear to proceed.
Launch director.
You have permission to launch.
ALC. Verified T0 is set for 1812 Zulu.
Verified.
1812 Zulu, that's UTC time, and we are go. And I got to tell you, it was nice to hear Tom Heater III give that go right there at the end.
Absolutely. I got goosebumps here, Daryl. Every time we get to this point in a launch, it is great to hear the team give their goes. And this is special for me, too, to dedicate this to Mr. Tom Heater II and hear Tom Heater give that proceed to launch. That is so, I can't even explain how I'm feeling right now. I'm so excited for Landsat 9 this morning. Looking forward to this launch.
His family and friends also here present to watch this with all of us. We are now counting down to the T-4 hold, where we're going to get those clocks synced up with the T clock and the L clock. This has kind of been a windy road to get to this point, though, Mick. This launch originally scheduled for September 16th. It moved to the 23rd. There were some issues with liquid nitrogen getting into the pad because of a COVID-19 induced issue with liquid oxygen back in Florida. So it created a shortage here. Moved past that. Also had a little issue with the spacecraft getting it up because of the winds. But Launch Services Program stuck with it, stayed the course, and got us to the launch day today.
Yeah, you know, I'm very proud of the team. NASA's Launch Services Program, our commercial partner, United Launch Alliance, the United States Space Force, they worked hard to get through this. It has been a windy road to get here, but you know, the team's dedicated. This is just part of the rocket business, and these guys have maintained their processes, followed through their procedures, and worked diligently to get us here today, Daryl. So I can't say enough about the teams that have continued to bring us here for Landsat's launch this morning.
As we approach the T-4 minutes, what do we expect to hear?
So we're going to hear them pick up the
On my
count.
mark, the time will be T-4 minutes and counting. 3, 2, 1, mark.
So we just heard now the L clock and the T clock will sync up. We are now entering terminal count.
3:55.
At T-3, we will hear the team secure topping and verify that everything's at flight levels. Around 2 minutes and 50 seconds, we will hear that the flight termination system will go to internal power, making sure that all the safety protocols are on the rocket as we launch this morning. And around 2 minutes, we'll hear that the Atlas and Centaur vehicle go internal on battery power, which means is a clear signal that we will be launching on time this morning. And then at 1 minute, we will hear the United States Space Force give us a range go or green thumbs up, and we will then proceed into our T0 mark for Landsat 9 this morning.
As you can see there, the rocket against a dreary backdrop with a marine layer and a little bit of fog. It's 93% humidity here along the central coast of California. It's about little less than 60 degrees in the temperature that's outside. None of that is a factor. Over the past few days, we've also seen some smoke from a nearby wildfire at Sequoia National Forest. There you're looking right down the side of the booster, the Atlas V booster, and seeing that condensation coming off that super chilled skin of the rocket.
Yeah, I love that shot, that rocket cam shot. That'll be a great shot as we lift off this morning. And as you said, seeing that super chilled tank as it filled with liquid oxygen and liquid hydrogen on the Centaur tanks this morning, we're just excited about this. And we just heard from the team that they're going to flight levels on the tanks, and so that's a good sign that we are getting ready to close those vent valves and move into what we call step 3 for flight pressures.
Once that rocket lights, that orange fire will certainly change the light and change the mood of many of the folks who are watching this. Certainly on TV, you're going to see all of that. We've got all the cameras focused in, all the angles on this rocket. You can see on the progress bar, we are go for launch. Our next point is liftoff.
Vehicle internal.
So we just heard the call, Daryl, for vehicle internal. That's a good sign. We're going to hear the last poll here to verify everything is go.
Securing Centaur LH2.
Securing Centaur LO2.
There's where they're securing and shutting off the vent valves and they're securing the vehicle.
Launch enabled. 137.
FTS armed.
Flight termination system is armed. We are getting closer and closer to that T0 mark, Daryl.
And there's a big moment at T-minus 45 seconds. What do we hear there?
We're going to hear the launch conductor, Scott Barney, verify from the last minute that everybody's ready to go, and we get a green to go for launch.
It's been a lot of work to get to this point, a lot of preparation. Let's listen in.
There we just heard vent valves locked, and as you saw, Daryl, you pointed out earlier that steaming off the vehicle has now stopped. The vent valves are locked.
Rock, report range status.
The range is green.
That is a great sign to hear range is green, Daryl, that we are good to go. Coming up on that poll from launch conductor Scott Barney.
40.
Stable at step 3.
$25.
Status check. Go Atlas. Go Centaur. Go Landsat 9.
And there it is, the word to launch Landsat 9.
T-minus 10.
9, 8, 7, 6, 5, 4, 3, 2, 1. Engine ignition. And liftoff. Liftoff of an Atlas V rocket and Landsat 9, continuing the legacy of an irreplaceable 50-year record on our ever-changing planet.
Control system response looks good. RD-180 engine operating parameters continue to look good. Vehicle has begun the pitch over maneuver. Body rates look good.
That pitch over maneuver heading it to the south towards Southern California and down to Mexico.
Now passing 40 seconds into flight. Engine operating parameters continue to look good. Pump speeds and injector pressures all within expected ranges.
There's a shot from our tracker cam above marine layer.
Now 55 seconds into flight. Vehicle is now completing the pitch over maneuver. Body rate responses continue to look good. 3 minutes remaining in the boost phase of flight. Pump speeds and injector pressures on the RD-180 continue to look good. Body rates continuing to look good. And at 1 minute 20 seconds into flight, Atlas is now supersonic, vehicle passing Mach 1.
A critical moment for the rocket.
And vehicle is now passing max Q, maximum dynamic pressure. RD-180 performance continues to look good throughout boost phase. Engine's now throttling down slightly as expected. Engine response looks good.
That throttle down reduces the stress on the 19-story tall vehicle.
At 1 minute 50 seconds into flight, vehicle is now 10.7, correction, 13 miles in altitude, 7.9 miles downrange distance, traveling at 1,500 miles per hour. Now just under 2 minutes remaining in the boost phase of flight. At 2 minutes, 18 seconds, the Atlas V vehicle now weighs just 1/2 of its liftoff weight. And vehicle's gone to closed-loop guidance. Body rates indicating a slight adjustment can be expected for this phase of flight.
There's a beautiful shot right there, looking back towards the planet, and see the plume from the RD-180.
And the reaction control system on the Centaur is now pressurizing to flight levels. System pressure response looks good.
So the reaction control system on Centaur, they're prepping it.
RD-180 engine operating parameters continue to look good throughout boost phase. Body rates remain stable.
Coming up in 60 seconds, the booster engines will cut off.
Flight. Approximately 1 minute remaining now until booster engine cutoff.
Our tracker shot getting a great.
And now 3 minutes, 15 seconds into flight. Atlas is 48 miles in altitude, 70 miles downrange distance, traveling at 5,600 miles per hour.
Great shot as it goes out over the southern Pacific.
Pump speeds and injector pressures on RD-180 continue to look good throughout boost phase. And the Atlas V is now throttling to maintain a constant 5G acceleration limit. Engine response looks good.
Speed currently 7,700 miles per hour.
Has begun boost phase chill down. Now throttling to maintain a constant 4.6G acceleration limit in preparation for BECO.
This is where the booster engine cuts off and then separates.
And we have BECO booster engine cutoff standing by for stage set. And we have good indication of Atlas Centaur separation. We have pre-start on the RL-10, standing by for ignition.
And there you see the separation.
We have ignition and full thrust on the RL-10. Chamber pressure looks good. Body rates look good.
Beautiful shot of the booster falling away as you're looking
and
down.
Good indication of payload fairing jettison.
And you should see the payload fairing. Sometimes they come around the side.
12 minutes, 11 seconds.
There you see one.
RL-10 performance continues to look good in the early part of this first burn. Now passing 4 minutes, 47 seconds into flight.
So we're in a good point, Mick. Flight is looking good. We're going to monitor the situation here. But what a beautiful launch. What a beautiful flight so far.
5 minutes.
But there's still a lot of work to do.
Yeah, absolutely. A lot of work to go on, but beautiful shot there of the RL-10 engine in space, sending Landsat 9 onto its orbit. A great launch this morning. So excited for this.
We're getting some of that orbital sunrise on the engine bell there, and that's just a neat look as you look back at our planet. All right, Marie, we'll keep track of things in here, but for the meantime, we'll send it back out to you on the hill.
All right, thanks, guys. We did get lucky enough for that marine layer to clear so we could see liftoff from here at the gravel pit. Earlier, I had the opportunity to speak with NASA Administrator Bill Nelson about today's launch. Take a listen. NASA Administrator Bill Nelson, thank you so much for joining us. You have described climate change as an all-hands-on-deck global challenge that requires action now. Tell us, how does the Landsat program help leaders take action now to address climate change?
We best get on the business of doing it right now. And what Landsat does, it is the longest continuous global satellite record of the Earth's surface. And these satellites have documented Earth's changing landscape. It helps farmers, scientists, understand and manage land resources, and all of that is needed to sustain human life. Such things as food and water and forest. And of course, Landsat's long-term record of our home planet allows us to track the changes and the impacts of climate change.
And President Biden's fiscal year 2022 budget requests $24.8 billion for NASA. That's a 6% increase from last year, and also the strongest budget NASA has ever had for science. How do you quantify the value of NASA's science missions?
It is a very strong budget request. The value is immense. And when you're talking about data like this, it's hard data that arms decision makers with the tools they need to make tough decisions about our future. It's exploration on other planets, helping to answer the age-old questions. How did we get there? Are we alone? It's the inspiration of the next generation. That is what this science budget is all about.
And besides Landsat, in what other ways is NASA making it a priority to understand and respond to climate change?
Well, we are doubling our efforts to lead when it comes to climate science. Earlier this summer, we announced a new Earth Systems Observatory. It's going to be 5 great observatories that will look at the land, the oceans, the ice, and the atmosphere, and combine a 3D composite of what is happening very precisely to our atmosphere. That, combined with all of our other existing assets, such as the Landsats, it's going to develop the ability for us to really measure what is happening. And also, we're continuing to develop resources for sustainable aviation. That is less pollution in the air from aircraft, and it will keep industry in U.S. competitive and drive fuel efficiency that helps the environment.
Administrator Bill Nelson, thank you so much for your time.
Thanks a lot. Have a great day.
All right, there is a live view on your screen now of Landsat on its way into orbit. Turning now to one of the many practical applications of Landsat, the U.S. Department of Agriculture uses it to track annual yield of every crop grown in the United States. Disaster managers can see impacts from floods and other natural disasters. Resource managers can use the data to direct crop rotation and monitor water use. Take a look.
America has always been a fertile land. Grasslands and forests and farms, from sea to shining sea. The U.S. Department of Agriculture tracks how many acres and the annual yield for every crop produced. From the big ones like corn, wheat, soy, to regional crops like cotton, rice, citrus. They track every year using data from Landsat satellites and others, combined with data from surveys on the ground. Landsat satellites see detail at the human scale, about the size of a baseball diamond, and can image individual farm fields. The program started in 1997 with North Dakota as an experiment. Other states became interested, and the program grew. In 2008, Landsat data became free to use, and the USDA could afford to map 48 states. During the growing season, the data helps estimate crop yields, which helps farmers and traders set prices for the harvest. Thanks to Landsat's detailed view, the USDA tabulates stats crop by crop, county by county, and state by state. At the end of each year, the data set is released to the public, and it is a beautiful sight. The patchwork of corn in yellow and soybeans in green in the Midwest. The diversity of crops in California's Central Valley. The clusters of citrus in Florida and California and Texas. We can see changes in farming through the years. The easiest to see is crop rotation in the Midwest, cycling between corn and soybeans. In northern North Dakota, there is a shift from barley and wheat to soybeans and canola. And we see an increase in cotton fields, shown in red, in Texas and Oklahoma. Thanks to the free and open access to Landsat data, the U.S. Department of Agriculture is providing our farmers with accurate data and helping maintain our nation's food supply.
All right, we want to bring in a special guest now from Northrop Grumman, the company that actually built the Landsat 9 satellite. Frank DeMoro, you are the Vice President of Tactical Space Systems for Northrop Grumman. And I understand this was your first launch out here at Vandenberg. How was it?
It was really special to see that rocket lift off.
Yeah, well, I tell you, we got a little lucky. It's also my first one, so we shared that together. But the last couple of days, the marine layer has been so thick, it's been very hit or miss, our view from here to the launch pad 4 miles away. So we lucked out. I'm glad you got to see it lift off.
Yeah, it was a special time, special time.
So this is Landsat 9 is the 4th satellite that Northrop Grumman has built for NASA. Tell us about the process. What goes into building a Landsat satellite and integrating it with the instruments?
Yeah, well, of course, the satellite that we build, the platform part of it, is really there to carry these special instruments to do the work that Landsat 9 is going to do. And so we have a dedicated team of engineers in Gilbert, Arizona, where we actually designed and built the satellite, working closely with our NASA customer to make sure that the structures and the power and all the data transfer systems are all in place to be able to accommodate the instruments. And then once we put that all together and put the instruments on the spacecraft, it goes through a rigorous test process. So that when we deliver it here and it gets launched like you saw today, it's ready to go.
There are so many things, as you know, that have to go right for a rocket launch to happen. And certainly the workers that you described in Gilbert, Arizona are a big part of that. All of the meticulous work I'm sure they had to do to get to this point. Can you talk a little bit about that team, what it's been like working through the COVID pandemic and any impact that's had at all?
Well, it's a really special team, and they're so dedicated to this mission. The fact that this is our 4th Landsat mission, partnering with NASA all these years in this type of mission, is really special. And the team understands that. And as they've worked through the past year and a half, they've just continued to work through the COVID period, being dedicated to this mission, knowing what it really means to NASA, what it really means to the nation to get this data down to the ground. So they've persevered, they've worked really hard, and I'm really so proud of them. Mainly, that's the main thing I'm most excited for today, is what the team gets to see.
Well, congratulations to you and the Northrop Grumman team.
Well, thank you very much. Appreciate it.
You're welcome. Thanks for being here. All right, we are now at launch plus 14 minutes, 37 seconds and counting. We expect Landsat 9 to reach orbit, its intended orbit, in just a few minutes, and here's some things to know about that. It will circle the Earth at an altitude of 438 miles. It will travel at 16,760 miles per hour, or 4.6 miles per second. Each orbit around the Earth will take 99 minutes, so Landsat 9 will complete 14 orbits per day. Landsat 9 will take more than 700 pictures of Earth every day. All right, and as I mentioned, we are approaching that orbit milestone, so let's get over to Daryl and Mick to take us through the next few minutes. Guys?
That's right, Marie. We are just seconds away from main engine cutoff. Centaur has been burning now for several minutes. It's really close. When this happens, we're going to be in an orbit that's a little bit higher. You just heard we're just about a minute out.
Yeah, so what's happening is we have this first burn, and we're trying to get a slightly lofted orbit this morning into that near-polar sun-synchronous orbit, Daryl, so that we can get Landsat 9 up there. What will happen is main engine cutoff will occur, and then we will coast for several minutes to get Landsat 9 into the orbit it needs to be, and then we will get spacecraft separation at L plus 1 hour and 20 minutes.
Hard to believe. We're just a few seconds away from main engine cutoff, but hard to believe this spacecraft and this rocket have gone almost completely around the planet. Currently coming up through eastern Africa, over Turkey. We're just seconds away. Let's listen in to the call for main engine cutoff.
And we have MECO, main engine cutoff. Body rates look good. Vehicle is now recovering from the shutdown transients.
And there you go, Daryl. We heard from United Launch Alliance commentator Patrick Moore, who's done a fantastic job since liftoff of filling us in on all the activities that have been going on, and we just got confirmation of main engine cutoff. So Landsat 9 and the Centaur will coast for a little bit, and then we're about 1 hour and 3 minutes from Landsat 9 separation.
Yeah, it'll coast for a lot of it, right? Because as you can see in the bottom of the screen, we have removed our progress bar with the milestones. and now have a new progress bar, which will show you the time to spacecraft separation, which you can currently see is set at 1 hour and 3 minutes. We'll be monitoring everything here, but once again, we'll send it back out to the hill with Marie.
Get up, get